This video explains how to define how two components rebound when they collide. Expand models by type in eCatalog and click Physics. Add block collider and cylinder collider. Move the cylinder onto the block. Click Snap in the Tools group. Put the cylinder to the center of the top face of the block. Use Move in the Manipulation group. Move the cylinder up along the z-axis. Set 1300 for the coordinate z in the Component Properties window. Perform the simulation. You can see that the cylinder does not fall and is not affected by gravity. Reset the simulation and set the gravity. With the cylinder selected, select the Physics Entity tab in the Component Properties window. Change physical type from kinematic to in physics. Set the simulation speed factor to 0.5 on the simulation control bar. The simulation execution speed becomes slower so that the fall movement can be easily seen. Perform the simulation. The cylinder falls and collides with the block. Let's check the details on how the cylinder collided with the block. Reset the simulation and perform the simulation again. You can see that there is a slight rebound. This rebound is considered as repulsion. Select the Modeling tab. In the Component Graph window, select Cylinder Collider, Behaviors, and then Physics Entity. In the Properties window, 0.1 is set to restitution by default. A coefficient of repulsion can be set between 0 and 1. When 0 is set to restitution, an inelastic collision occurs so that the cylinder does not rebound. Perform the simulation. The cylinder does not rebound and remains on the block. Reset the simulation. When 1 is set to restitution, a perfectly elastic collision occurs so that the cylinder rebounds. Perform the simulation. The cylinder rebounds hard. Reset the simulation. Set 0.5 to restitution. The rebound force is about half as compared to that when 1 set to restitution. Perform the simulation. The cylinder rebounds a little and remains on the block. Reset the simulation. Select the block. In the Component Graph window, select Block Collider, Behaviors, and then Physics Entity. In the Properties window, set Physics Type to Out of Physics. Perform the simulation. The cylinder passes through the block and rebounds. Since the block is not affected by physics, the cylinder passes through and collides with the floor and rebounds. Let's create a conveyor and check how the cylinder falls on the conveyor. Open the Home tab. Expand models by type in eCatalog, select Physics, and add Conveyor, Physics. Select Cylinder Collider to add one cylinder. Click Snap in the Tools group. Put the cylinder to the center of the top face of the conveyor. Use the Move function. Move the cylinder up along the z-axis. Rotate it about 40 degrees along the x-axis. Perform the simulation. Since physics type is set to kinematic, the cylinder does not fall. Reset the simulation. In the Component Properties window, change physics type to in physics. Perform the simulation. After the cylinder collides with the conveyor, it rebounds a little and flows over the conveyor. Let's check the operation when the cylinder falls in a perfectly elastic collision. Select the Modeling tab. In the Component Graph window, select Cylinder Collider number 2, Behaviors, and then Physics Entity. In the Properties window, change the default value 0.1 to 1 in restitution. Perform the simulation. The cylinder rebounds hard. Numerical values are input in static friction and dynamic friction, indicating that friction occurs. Reset the simulation. Change the value to 0.3 in restitution. Perform the simulation. Compared to when 1 is set, the rebound force of the cylinder becomes smaller. This is the end of the explanation of how to define the repulsion when components collide. Thank you for watching.